where we left off yesterday is we were graphing this guy, and I said the book suggests to do this. We take whatever the input to the trig function is, and we put it inside its one full period. And it could be from like negative pi to pi, whatever. The easiest one to do is from 0 to 2 pi in the case of sine and cosine. So we did this. Then we got the x by itself, right? So this is just, like I said, we're going to do this down and dirty. It's going to look a little bit different from the way I did it yesterday. You'll see why in just a second. I'm going to divide everybody through by 2 to get the x by itself. Dividing that gives me a pi. Dividing that gives me a plus pi over 4. One of the reasons I did this is it's nice to see right away what the new period is. You can easily tell what the new period is because, well, if that's the old period, that's your new period, because you're basically taking, it says start at that point and keep adding stuff until you get to pi plus that point, right? And so you could see, like, here's your pi over 4, and then you go to some number plus pi over 4, whatever that number be, whatever that number is, must be the new period, right? So it's kind of nice to see. And we'll also see this thing has a pretty cool, this thing by itself has a pretty cool interpretation in just a minute. So this is where we started, and we said, okay, if that's the new period. Now, another thing, we didn't explicitly talk about this yet. Because this is just plain old sine, it hasn't been stretched. In other words, its amplitude hasn't changed, right? It's the amplitude is still 1, meaning it goes up 1 above the axis and down 1 below the axis. We don't really need to use our brains as far as where is this going to show up on the graph. It also hasn't been shifted up or down, so we don't need to basically plan ahead. We could just cut to the chase and draw it on the graph, the actual x-axis. So that's what I'm going to do. I'm going to say, okay. So it's going to go from pi over 4 up to pi plus that much, which we did last time as 5 pi over 4. And then knowing that not just a sine curve, but also a cosine curve, right? It has, from the first place, it has 4 other interesting points. It has this point, 1, 2, 3, and then finally 4. Ditto with cosine. Starting here, you have 1, 2, 3, and 4. And so if we divide this interval, whatever it happens to be, up into 4 equal pieces, then we'll be able to just count over and find out where all of that stuff curves. Like I said, down and dirty, I'm just saying all this stuff real quick. And so we know that the period, we could look at this and see that the period is pi. The new period is pi. Or we could use the new period is 2 pi over whatever, I'll get you, Peter, whatever number is out here in front of the x, or in front of the input variable. The number happens to be 2, so we could see then the new period is pi. A couple different ways of thinking about it. They're both equivalent. And if we're going to take that new period and chop it into 4 pieces, we literally just take the new period and chop it into 4 pieces. We divide by 4. Now I'm going to count by pi's over 4. Starting at 1 pi over 4, I go over to 2 pi over 4, 3 pi over 4, 4 pi over 4. And remember, I said, don't bother reducing these. Like, that's just a waste of time. And like, this is nice to be able to see that you've done everything right. If you've reduced it and you've done pi over 4, pi over 2, 3 pi over 4, 2 pi over 3, 5 pi over 4. If you went ahead and reduced it, wait, 4 pi over 4 is pi. See, you see, like, it's easy to mess this up. But also, if I look at that, I don't know, I can't just right off the top of my head see if I've done that the right way. But as I look at this, I can see, yes, 1 of them, 2 of them, 3 of them, 4 of them, 5 of them. everybody's good. So that's how I suggest doing this. You don't have to, but whatever. Do your own thing. So, okay. Now we know that's one full period. We know that since this is sine and he hasn't been flipped or anything like that, he hasn't been stretched or whatever. This is sine, so he starts here at 0, goes up to 1 here, comes back down here, goes down to -1 here, and back up like that. Looks terrible. And so that's where we left off. Okay, so now the way that I want you to graph stuff, anytime we're graphing something like this, you need to show what happens across the origin here. Juliana Burry entered the waiting room. Okay, welcome, Juliana Burry. There we go. Okay. So this is where we left off. And basically we're just keep counting by this because this thing is it's periodic. This thing just repeats, right? This is just the same picture. It just keeps repeating and repeating. And the way I would do this, if I were you, I would just keep counting by our, we've divided one full period up into 4 bits. This is the step size of that bit. Just keep taking those steps. You're at 5 pi over 4. If you want to keep going this way, you can. You could go to 6 pi over 4, 7 pi over 4, and so on and so forth, right? To get that. What I definitely want you to do is to continue on that way, right? So we're always going to show where it crosses the y-axis. And in this case, I haven't drawn it to scale, so it's going to look very funky. But here, have it you, bud. And so, since I know, like, we go from 0 up to 1, 0, down to -1, 0. So if I'm going backwards, we're at 0, 1, 0, it should go to -1. Pi over 4 comes back to 0 there. Like I said, I probably should have drawn it better, but I didn't. And so this comes down to -1 right there. Comes back up. I'm just still counting by pi's over 4. So you're at 1 pi over 4, 0 pi over 4, negative pi over 4. And if I were to continue on, it would be -2 pi over 4, -3 pi over 4, and so on and so forth. And so we have that right there. Come here, bud. Oh, stop it. Okay, so we'll see how well this works. So, okay, moving on. So this looks terrible, but ultimately, Peter, no, not right now, bud. Ultimately, it should look something like this. Down to 0, comes back up, and so on and so forth, right? We're going to mark where it goes through the y-axis here at -1. We've already marked all these points. I'm just, not doing it officially anymore because I'm holding a baby. And so we also want to mark what it's the range, right? The output values. We have the highest output value we're going to mark, the lowest output value we're going to mark, so on and so forth. Now, there's yet another way of thinking about this. And this way, I do like this way of doing it, where we chop it up and we find one full period and then we just repeat the periods on either side, and et cetera, et cetera. There's another way of doing this. I'm going to leave this up here so we could check our work and see that, yeah, that's what we got. But before we do that, let's do a little exercise. Let's suppose that I have some function, f of x. And let's say it looks like this. I'm just going to completely make something up. How about here, comes up, goes down, goes back up. And then from here, it bounces back up. Let's say that this is at 1, this is at -1. Let's say that this is at, it doesn't matter. And let's say that this minus part is at 2. Or sorry, the minimum part here is at 2. Now, if I told you to graph this function, would you be able to do that?
Yeah.
Right? Like, what does this do to the graph of the original function?
Shift it to the right too.
Shifts it to the right by how many units?
2
Units. This would do what?
Left.
to the left.
It would shift it to the left by 2 units. And so if I said that, you could just say, well, there's my 2. It's 2 over, and whatever this output, the minimum is right there, I would shift it over 2 units, and it would end up right here. This would come up. This thing would go up. It would go back up, and so forth. And you could find all the other points. You could find that this point, sorry, that ended up right there. It was at -1, but it got shifted 2 over, and so it must be at -3, so on and so forth, right? You could do all of this. Does it matter what f originally was?
Not really.
Not really. No, it doesn't at all. And so, for instance, if it happened to be the case that f of x was sine 2x, you could say, well, like we talked about, that's just a compression. It's just compressed it so that now instead of going all the way out to 2 pi, it's been compressed by a factor of 2. It only goes to pi. This would be pi over 2 right here, so on and so forth. You'd say this, instead of being pi over 2, is pi over 4. I'll get you in just a second, Peter. All right. And then if I said, all right, hey, why don't you draw this? F of x minus pi over 4. You'd say, well, this is that. This is the same thing as that. And it's just that this thing right here that was at minus pi over 4 has been shifted to the right. Right? So we're going to shift the entire graph to the right by pi over 4 units. So this point that's right here needs to come and be here at the bottom. And then it continues on, and we could see that all the other guys just get shifted over. So the thing that was at 0 is now at pi over 4. The thing that was at pi over 4 is at pi over 2. The thing that was at, and so on and so forth, is pi. The thing that was at pi is now at pi plus pi over 4, so that must be 5 pi over 4. Right? So on and so forth. Now check this out. Let's just see what that is. If I plug this in. If I just plug this in. Now this is where I've said this since day 1 of last year. Parentheses are your best friend. I'm going to go ahead and rewrite f of stuff as sine of 2 times whatever the stuff is. And when I plug this in right here, please use parentheses. Parentheses are your best friends here. You really want to use parentheses. And so x minus pi over 4 gives you an x minus pi over 4. And you'll notice that this is the exact same thing as this. Isn't it? I gotta put you down, but here, take this. This, you're way too heavy. There you go. And so this is what I'm getting at here. And you'll also notice that this looks terrible, isn't that long? But you can see that I've reconstructed the exact same graph that way. And so another method you could use to do this is to say, well, hold up. We take our given function with the weird input that we have, and if we just factor out whatever number this is, think back to factoring stuff like this, ax squared plus bx plus other stuff. When we factored out an a to get it into the form that helped us out, all we had to do was just throw the a in the denominator right there, right? So this isn't a hard thing to do, and you could do this pretty easily here. We could just say, well, you know what? Because the idea is this. If I could rewrite this in this form, I could think about this thing as sine having just been compressed, which is super easy to do. Or if it's like 1/2 or something like that, then it's been stretched. Still super easy to do. And then I could just figure out how far it's been moved one way or another. And so factoring out a 2 leaves me an x. Factoring a 2 out of here puts a 2 in the denominator, making that a 4. Lo and behold, this is another way you could think about this. And you could say, okay, just like we just talked about, I know what this function does. So if this were just an x right there, I'd say, well, that's just sine of 2x. You've just compressed it. And so you could say, well, this guy gets compressed. And so now he's here at pi over 2, pi over 4, negative pi over 4. And then we're taking, so this is just sine 2x. But now we do the shift. And so you could say, aha, shifting the input over pi over 4 moves this guy who is at pi over 4 1 unit this way and brings everybody else back. And so everybody gets shifted over pi over 4. So here's pi over 4. Here's 1 pi over 4. How about 2 pi over 4? How about 3 pi over 4? 4 pi over 4, 5 pi over 4, and so on and so on. So that's another way of doing it. And when I said I sent out an email saying Trig's about to get hard, it's kind of what I mean. Now I'm giving you the opportunity to find the method that you like best. And oh, buddy, here, try this. Here. So that's another way of doing it. We're gonna do a bunch of examples, and some of them I'm gonna do one way, some of them I'm gonna do the other way, and you could either decide now, or if you want, do them both. Like that's gonna make this assignment very long, but or you could do one way, do one the other way, and by the time you're done, you'll see which way you like better. There's pros and cons to both ways. Another thing I didn't explicitly state it here because we did it so many times. Like I was using the fact that I knew what a quarter of the period was here when I started counting this thing off, right? And I didn't explicitly say when I did sine 2x, I didn't bother finding the new period because 2 is kind of easy, right? They're about to not be easy at all. And so what we'd have to do is say, well, hold up, what's the period for this guy? The period is 2 pi divided by whatever that is. So the new period is pi. Therefore, a quarter of a period is whatever that is over 4, and so on. I just didn't explicitly do it. So I want to start with one that's kind of easy. Actually, no, let's just go for it. So that's the one. Okay. Any questions before we move on? I'm going to erase all this stuff. Okay. Oh man, I erased that. So one more thing. So last time I said for any function, f of x equals a sine bx plus c, or if you have a function equals a cosine bx plus c, then we defined a as the amplitude, and it's actually the absolute value of a is the amplitude. Right? So if it's negative, doesn't matter. It's still called the absolute value of it is still called the amplitude. Because, and remember, that's not the total length, right? That's this length from there to there, right? It's the same length from there to there. Okay? Now, we said that 2 pi divided by the absolute value of b is what we're calling the period. And we've seen that a bunch of times, like why that's the case. stretching and all of that good stuff. Now there's one more thing. So in the homework, it's going to say, find the amplitude, the period, and the phase shift. It's the one thing we haven't talked about. And I was saying, and I wish I would have kept this up there, we had, sorry, it was pi over 4 x. Pi came down to pi plus pi over 4 right there. This bad boy is called the phase shift. How did we obtain it? Well, if you think about it, we started off with bx plus c between 2 pi and 0. We brought the c over. Then we divided everybody by b. Hey, buddy, will you keep dropping your stuff? You should stop dropping your stuff. I know it's fun to watch it fall, but if you drop it, you won't have it. That's what happens. Then when we divide by b, we have c over b less than x, 2 pi over b. Oh, hey, look at that. Interesting. Minus c over b. And this entire thing right there, minus c over b, is what we call the phase shift. And it's really, once you've compressed your function by a factor of b, compressed or stretched by a factor of b, it's then how much you move in one direction or the other. So, like in our case, we had sine 2x minus pi over 2. Pi over 2 is not the phase shift, because we're talking about how much you move after you've compressed or stretched in the horizontal direction. So, and as you can see, how did we go from that to our nifty new form? Well, we factored out a 2, giving us x minus pi over 4. Lo and behold, that's the same thing that happens right here, right? If I factored out a b, I'd have a c over a b, right? So the sign, the plus or minus of this thing also tells you which direction it's going to be. In this case, right, it was, and notice how we've done this, right? Because we're assuming it's a plus. It's the same kind of thing as like the quadratic formula. You assume it's a plus, and so then if you plug in a negative, it takes care of the minus and all that stuff, right? But the minus c over b, that gives you the direction of where your origin has now been shifted to. So in our case, we had sine, and we know that sine starts right here. And since the phase shift was a positive pi over 4, this was the point that got moved over to pi over 4, the positive pi over 4. If it were cosine, then we would have, since cosine starts up here and comes down, then we'd know that with a phase shift of plus pi over 4, it would move us plus pi over 4. You could always check yourself by just looking here and going, well, if that's a minus, I know I'm going to be shifting to the right. And yes, that's what the minus does, right? The minus makes it a positive and all that good stuff. So that's another thing you're going to have to identify for the homework. We have, this is sine. This is just plain old sine right now, because we have it set up with a times sine. So a is going to be the amplitude, a times sine of bx plus c. So as of right now, a is 1, b is 1, and c is 0. So this is just plain old sine x. As you can see, he starts here at 0, and at pi over 2, he reaches a maximum. Down here at pi, 3.1415, blah, 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 we come back down to 0, and so on and so forth. So now let's just think. Don't say it out loud. But I want you, here's an exercise. I want you to think what's going to happen. And then if that happens, you're right. If not, tell me later and I'll give you a 0 for today. But no, I'm going to slide the B slider to the right. That's going to make the number, that's going to make B bigger. You tell me, or you just think, what's going to happen to this graph? Think about it. Okay, now let's do it. Is that what you expected to happen? Right? Because when we multiply the input value by a bigger number, right, it should be a compression. All right. Now I'm going to slide it to the left to get us back to 1. Oh, he hit me. Okay, so now I'm going to slide this guy. Whoa, 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 whoa. Now I'm going to slide it to the left. It's going to take on values closer and closer to 0. Think about what's going to happen. Oh, yeah. And yes, it's stretching out, as you can see. And I didn't set this to be very fine. But now try to think of what's going to happen when the slider's going to get to 0. Think of what it should look like. And then I'm going to take it down past 0. And we're going to start taking on negative numbers. Okay, so just take a second and think about what it should look like when it first hits 0. And then when it becomes negative. We didn't talk about this, but if you think about the analogy between what happens when we multiply the output of a function by a negative number, it's very similar to what happens here with the output of a function. So I'm going to stretch this guy. There we go. Getting down to 0. Oops. And when it's 0, it's just sine of 0 forever. Sine of 0 is 0. And so the output is always 0, no matter what. No matter what x you plug in, you're taking that x and multiplying it by 0. And so it's always just sine 0. Oh boy, you are loud. And so now I'm going to go to the negative side and let's see what happens. And when I'm down here at -1, notice what's happened. You could think about this as we have reflected the original graph of sine. We've reflected it around the origin. I'm sorry, around about the y-axis, right? And so that is what multiplying the input of a function by a negative number does. It flips everybody around. It used to be that when you run over to pi over 2, sine was like, over here at pi over 2, I'm going to put out a 1. But now when you run down to negative pi over 2, the function says, well, make that negative and then give me the old thing that you got, right? Bunch of different ways of thinking about this. This is a reflection. And we can see what's going to happen as I keep stretching it. It's going to now compress it in that direction. Okay, so let's get back to just regular old sine. Regular old sine. There we go. Now let's get rid of blue sine. Now we just have red sine. Okay, so now let's think about what's going to happen when I play with C. All I'm going to do, so what we're going to have is just plain sine, because A is 1, B is also 1, so we just have sine x plus C. Now let's think about it. You try to predict what's going to happen if I slide the C slider to the left. That is, we're going to make C a negative number. So we're going to be adding a negative number to this. And you think, what's going to happen? Let's do it. As you can see, right? The more we shift it, the more it moves to the right. It does the opposite of what we expect, right? Just like we talked about before. Okay. And if we move it to the right through positive numbers, it shifts to the left. Okay. The only other thing really left to play with here is the amplitude. Try to think about what's going to happen when I make this guy bigger. We're at 1 right now, so it's just plain old sine. But now when I make it bigger, what's going to happen to this graph? Yes, indeed. It stretches vertically. And you can see that the zeros, the parts that, just like I said yesterday, the parts that go through the x-axis do not change. So those output values are 0. You take 0, multiply it by 0, it stays 0. These points are not moving. Now I'm gonna take this and slide it down through negative values.
Okay, so let's get our original sign back. This is just 1 right now. And I am going to now slide it down to -1. And think about what this should look like. Okay. Oh, hitting me, man. That would have been a lot smoother if you hadn't hit me. So yes, you multiply all the outputs by -1 and it flips it upside down. And so if we're thinking about, oops, whoa, wow, I just happened to hit something very close to pi. That's interesting. So no, that's not what I want. That's what I want. Back. Stop it. So regular old sine is the green one. -1 times sine flips everybody upside down. Go figure, right? So, and of course, we could then play with all of these, right? And do a bunch of different things, put them all together, right? And this might be a good thing to play with as you're starting to learn this. Maybe not. If it helps you, cool. If not, there you go. I just wanted to kind of show you guys that. If you need parameters like that, I just got rid of it. But if you need parameters like that, as you start to write in a function, you could just choose A, B, and C. And then when you hit enter, it'll say like add them as parameters. If you just hit enter when you're done with it, it'll just automatically add the parameters with the sliders and stuff like that. So you can do all that stuff. Okay. All right, buddy. I think if I keep moving this guy, he will he might be a little bit more quiet. So okay, Pete. Look at here, where'd your feet go? Your feet are gone. Okay, so let's do a difficult one. Oh, yeah, that's the one I wanted. Okay, yes. So this is from your homework. This is number 28. Number 28, and this is for all of these, this part of it, it says, find the amplitude, period, and phase shift, sketch the graph of the equation. So the equation here they've given is y equals -4 cosine 2x plus pi over 3. Okay. So here's what I suggest. You start these. So, well, let's get the stuff it asks for out of the way. What's the amplitude of this?
-4. Oh no, just 4.
Absolute value. Absolute value. The amplitude is always going to be a positive number, just by definition. Like, yes, the number out there is -4, but it's the absolute value of it. So it's +4. Now, what's the period? Somebody better answer.
Pi.
Yes, pi, because what we do is we take the old period, divide it by whatever that number is. It happens to be the same thing that we've been working with, right? And absolute value happens to already be positive. You're gonna have to wait, Pete. And so we get pi. 1 full period is pi. No, you do not grab this. Now, what's the phase shift? A couple different ways we could think about it. Woo!
Pi over 3. Oh wait, no.
So the formula was -c over b, where that's b and that's c. Another way we could think about it is if we actually factored this guy out. No. If we actually factored this guy out right there, then whatever's left in there, the negative of it will be the phase shift. So in this case, what do I get here? Obviously it's plus because I haven't factored out a negative. So what's left?
Pi over 6.
Pi over 6, right? If you're factoring something out, just put it in the denominator, right? So the 2 comes into the denominator. 3 times 2 is 6. And so the phase shift, you could, or you could do it this way. You could say negative C is pi over 3. Divide by B, which is 2, which is negative pi over 6. Okay, a couple different ways of doing it. Or you could factor it out and then say it's the negative of whatever that is. Or another way of thinking about it is this is where your origin is going to get moved. Since you're messing with the, since you're messing with the input, right? The plus is going to move you in the negative direction. And so you could say, you'd be moving left by that many. And so a bunch of different ways of doing it. Why don't you eat your sandwich? You want your sandwich? Yeah, here. All right. Here you go, bud. Here, sandwich. Okay. So okay, that's what it asks you to identify. That's how you do it. Now, let's go ahead and do this both ways, right? So now that we've done what it told us to do, now we have to graph it. The first thing I'm going to say we need to do, or that I'm going to recommend the first thing you do with graphing is you take care of the input first. And we've talked about two different ways of doing this. One way is where we say, okay, cosine has one full period between 0 and 2 pi. But now the input value is 2x plus pi over 3. And so now I'm going to go ahead and get x by itself and give me a minus pi over 3 less than 2x less than 2 pi minus pi over 3. Okay. Now we could, if we were so inclined, combine these. I don't really feel like doing that right now. I'm going to go ahead and divide everybody by 2 to give me minus pi over 6 less than x less than pi minus pi over 6. A nice thing is if you're going to do this, this takes care of 2 of these problems right here, right? So if you know, like the question's telling you to do this, this might be a good method to go ahead and do all of these with, because you know that when you get down to here, if you've left it like this, there's your answer, right? The first thing right here is your new period. And then whatever that is with its sign included is the phase shift. That's pretty nice. And so now the next thing I'm going to do is take one full period and divide it into 4 bits. I'm going to say, well, that one full period is pi. Dividing it by 4 gives me pi over 4. That's cool. And so now we're going to say, okay, one full period occurs from here to here. And this happens to be, let's see, 6 pi over 6. That's 5 pi over 6. Everybody buy that? Right? Pi minus pi over 6 should be 5 pi over 6. Oh, stop it. And so, here we go. This is where it's hard, isn't it? Because look at that. You're like, well, I'm going to start at minus pi over 6. Now I have to count by pi's over 4. Oh no. This is terrible. What are we going to do? And you could, if you wanted to, like add, okay, well, I guess minus pi over 6 plus pi over 4 and all that. What I'm going to suggest you do to make your life so much easier is to just go ahead, start with a common denominator. Pi over 6, so 6 and 4. Well, I mean, we could just use 6 times 4. Or we could say multiply that one by 3, multiply that one by 2. And I guess 12 would work. Right? Yeah, so let's use 12. And I'm going to say, okay, the new step size. That's what I'm going to call this, the step size. It's the same thing as 3 pi over 12. Yeah? Right? Okay. This guy, pi over 6, is the same thing as negative 2 pi over 12. And 5 pi over 6 would be 10 pi over 12. Oh man, this guy keeps kicking off the wall. I shouldn't have had him facing out. This is so annoying. Okay. Okay, here we go. Okay, so everybody following what I've done so far? Okay, so instead of being here at minus pi over 6, we're at minus 2 pi over 12. Now I'm going to count by 3 pi over 2. So if we're at the step size is 3 pi over 12. So minus 2 pi over 12. 3 more will bring me to 1 pi over 12. Right? Yeah. So 1 pi over 12. 3 more should be 4 pi over 12. 3 more should be 4, 5, 6, 7 pi over 12. Stop it. Ugh. 3 more should be, oh, thank goodness, 10 pi over 12. Now, this is cosine. Okay, so before we were starting here because sine started here. Not anymore. Cosine starts up here and then comes down and then back up. And so this goes down to 0, down to minus 1, up to 0, up to positive 1. And there's 1 full period of this guy. Isn't that fun? So, oh man, look at that. So, let's see. So, but this, what have I just drawn? Have I drawn -4 cosine? No, this is all I've done right here. This is just cosine. Regular old cosine. 2x plus pi over 3. And so in this case, he's going from 1 down to -1. Buddy, please just chill out. Here, play with this. Play with this. You need to chew on something, bud? Chew on that. Okay, so if we multiplied this by 4, it would stretch everybody up and down by 4 units, right? 4 in the up direction and 4 in the negative direction. And so, well, what picture would I end up with? This right here. Instead of going up to 1 and down to -1, it would be up to 4 and down to -4. The only thing left, so that's what this is right there. The only thing left to do is flip it. We're going to flip it upside down, right? Because we are trying to draw the negative. Okay, so what I'm going to do is just qualitatively here, just kind of see, okay, it should come from down here, move its way up to 0 here. So this right there. And now I'm going to label my minus 2 pi over 12. This is my pi over 12. This is my 4 pi over 12. This is my 7 pi over 12. This is my 10 pi over 12, like that. Now, I'm not going to make you guys, we happen to have the zeros here, right? We have but they're already marked. So the X values, we don't need to label. And it's going to be way hard. Oh, and by the way, one thing I didn't do, sorry, -4 up to 4 right there. I'll tell you what, for this homework, as long as 1 full period goes through here, you only need to draw 1 full period. If it doesn't, like in our first example, the full period was outside, take it back or take it forward so that it does go through. One thing I am going to require is that you label this point right here. What's that? How do we find the output of a function if we know the input? What's the input right there?
Plug in a 0.
Plug in a 0. Plug in a 0. And so when I plug in a 0, I get -4 cosine Well, the 0 takes care of that first part, so all we have is pi over 3. Cosine of pi over 3 is?
Oh. Root 3 over 2? Wait, no. Oh, 1/2. Oh.
1/2. I'm not going to draw the triangle because you could draw the triangle, and it's 1/2, and so this is -2, so that's -2. As you can see, this is nowhere near being accurate, right? But it's qualitatively accurate. This point down here is lower than that point right there, so we're good. Now, what if? I'm not sure if this is going to come up in this homework. I don't think it will. You should be able to get exact values at every one of the zeros here. But in case you can't, like let's say, for instance, you plugged in your 0 and you ended up with something like this. -4 times cosine pi over 7. I don't know how to do that. And so this would be an exact answer. You just write that right there. Okay, if it's one that you don't know how to deal with, in other words, if it's not like a multiple of pi or a multiple of pi over 2 or over 3 or over 4 or over 6, you don't know how to deal with it. And so this is a perfectly good answer. This is an exact answer. Ditto if it happens to be something like this, cosine, I don't know, 3x and then plus 1. At 0, you plug in a 0 and you get cosine of 1. What is cosine of 1? It's cosine of 1. That's what it is. That's the exact answer right there. If you can't evaluate it, like with pi over something, or going back to the triangles that we've done, or from the graph where it actually goes to 0 or 1 or -1, just write that. Okay. Questions before we do another, or before we do it the other way, because I'm going to need to get rid of a lot of this stuff. Any questions? Okay. All right. So it's one way of doing it. The other way of doing it would be to start here. We factor out whatever that is, and then we end up with this. And I would say, well, you know what? Why don't we start with cosine 2x and see what it looks like? Cosine of 2x squishes everybody by a factor of, and cosine comes up. And so it goes up to pi, down to -pi. This is pi over 4. This is pi over 2. 3 pi over 4, and so on and so forth, and everything. And now we're just taking that and shifting it which direction by how much?
Left by pi over 6.
Left.
Oh, wait, no.
Left by pi over 6. Yes. Okay, Pete, I got you. I got you, buddy. How are we doing on time? I'm gonna run over a little bit today, guys. Oh, if either of you guys have to go because you have lives, just feel free. You don't have to say anything. You could just peace out and everything. I'm gonna continue on, even if both of you guys go. That way we could get this online and have examples and stuff like that. So okay. So now from here we can move it to the, just like you said, left by pi over 6, and now. That's also comes with its problems, right? Because I have pi over 4 here. I have a negative pi over 4 here. -2 pi over 4, and so on and so forth. And now I need to take that and move it left. And so again, you're trying to move something that's over 4 by over 6. You're still going to need to find a common denominator. And I would say that should be the first thing you do. We already reasoned that we should use 12. You could use 24 if you want. That would be cool too. So I'm going to relabel this, and I'm just going to do this half right now. This, instead of being pi over 4, would be 3 pi over 12.
this instead of being pi over 2 pi over 4 would be 6 pi over 12. And so on. Instead of being 3 pi over 4, he would be 9 pi over 12. Instead of being pi, that's 4 pi over 4 multiplied both by 3. Oh yeah, of course, 12 pi over 12. I could have just counted. That would have been easier. Now I'm moving all of them over by pi over 6, but pi over 6 is the same thing as 2 pi over 12. So everybody needs to get minused off by 2 pi over 12. And so the 3 pi over 12 moves over 2 units to be at, or 2/12 to be at pi over 12. The next one, 6 goes over 2 to 4 pi over 12. The 9 goes over 2 to 7 pi over 12. And the 12 goes over 2 to 10 pi over 12. Those are some familiar numbers. Here, bud. Here, hold on to this. Hold on. And so that was this point right here. And so it comes down, comes back up, goes up, and so on and so forth. We know that this thing that was at 0 is now at minus pi over 6, or the 2 pi over 12, or what, minus 2 pi over 12 and all that good stuff. But then we need to do our stretch and our flip because of that, so on and so forth. Same thing that we just did. So I don't think I need to show that. Like it's the exact same thing we just did, right? There's no difference between those two methods once you get to that point. Questions? Hard stuff. This is boy, there's so much going on here. So much going on here. Let's do another hard one. I had one more hard one I wanted to do. That's so okay. Oh no, that didn't have the thing I went. Oh well. All right, well, that's fine. We'll do that. Okay. Buddy, you just grab everything. It's like you're 6 months old or something. Okay. Hold on to this. All right. All right. It's going to kick us off before too long, but we'll do that in just a second. I'm going to set this up. So this is number 38. Same deal. Y equals. That's not bad at all, actually. No, I'm sorry. That's not the one I wanted. I'm sorry. I'm looking at the wrong number. I wanted to do 40. 40 was minus 4. Again, sine of stuff minus 3. And this is 3x minus pi. Here, grab this. Okay. Now, things are going to get real ugly because of this shift right here. That's gonna make life much harder for all of us. And so, we'll get there though. We'll get there. Right now, let's just do because it wants amplitude, period, phase shift, amplitude. Well, it's the exact same thing as last time, and I'm going to bother asking you. So it's this. The period now, it's 2 pi divided by that number right there. So that's 2 pi over 3. Phase shift is then, and there's a couple different ways we could do this. We could factor out that 3. We can do that. And we can see the phase shift is the negative of that, or if you think about where this thing is going to get shifted, it would be shifted to the right, and it would end up at pi over 3. So the phase shift is pi over 3.
There's that. Now, as with everything, we're going to take care of inputs first. And so the inputs, we have one full period when 3x minus pi goes between 0 and 2 pi. I add pi to both sides. Since we've already figured this stuff out, I'm just going to actually do it this way. Just go ahead and just cut to the chase there. Okay. Is that right? I add pi. I add 1 pi to 2 pi, I get 3 pi. Yes. Okay. Now I divide by 3. And I get pi over 3 x pi. Now I'm going to go ahead and add my fourth thing, which is what is 1/4 of the period? So if the period is 2 pi over 3, if I divide that guy by 4, let's see. This guy cancels with one of them, and we get the same thing as pi over 6. Okay, so pi over 6 is going to be the step size of one full period. The period's going to run from pi over 3 all the way to pi, and then I'm going to chop that into pi's over 6.
I have to go.
Okay, all right, well, I'm going to get this all up online sometime, hopefully by tonight, so you could see the rest of this stuff later. Although, like, you don't have to do it Justin's way. Like, you could, if you could handle this, which I think you can, you do it however you want, but I'm going to have some suggestions and stuff like that. So take care. Nice seeing you.
Thank you for class.
Okay, so here we are, minus pi over 3. I also know that this thing's going to be shifted. So I'm going to go ahead and draw a dotted line for my x-axis, and then I'm going to put the actual x-axis in later. But also, but knowing that I have this thing going on, I know I'm going to need a couple of different things before I actually get to my final bit. So I'm actually not going to worry about that just yet. I got you, Peter. There you go. I got you. So let's just start here. Here's pi over 3. But another thing I know is kind of like the problem last time. It's not easy to add pi over 6 to pi over 3. So let's get a common denominator. And I'm going to say, instead of pi over 3, how about 2 pi over 6? So I'm starting at 2 pi over 6. And I'm going to count by pi's over 6. So we're starting at 2 pi over 6 over to 3 pi over 6 up to 4 pi over 6, 5 pi over 6, 6 pi over 6, and lo and behold, that's the same thing as that. So I feel good, right? We've taken 1, 2, 3, 4 steps, and I've ended up where I should be. That's another way I can check myself to make sure I'm doing this right. Now, this thing is sine. So I know that sine starts at 0. One full period of sine, assuming that we're starting at 0, starts off with the output value of 0. So it goes up, comes back down, goes back up. Yeah, bud. And so, oh yeah, you think so? Cool. So, and here's another thing. Now I need to walk backwards, and I was a bit too, I started off with, I shouldn't have drawn the y-axis even to begin with. I would suggest you don't draw your y-axis till the end. That's what I've been messing up on every time. Now I'm going to just walk it back. We're at 2 pi over 6, so working my way back, I go 1 pi over 6, 0 pi over 6, and that's where I'm going to bring in my y-axis. We're going to have a negative 1 pi over 6, negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6, and I'm running out of room, so that's sufficient. And like I said, as long as you span the thing, you could have stopped right here at not minus pi over 6. That's fine with me. But now let's think about how this works, right? This comes down here at this one. It should come back up at this one. So it should be that we come down to negative 1, back up here, down here, and back up like that. That should work. And now I'm going to check myself. Because it should be that if I plug in a 0 into this function, it says I get out a 0. Well, at least this part of it. This is all I'm really looking at now. I'm looking at the sine part of it, because what I'm trying to draw right now is sine of 3x minus pi. That's what I'm drawing right now, because we haven't gotten to the stretch in the shift yet. This is all this is. And so it should be the case that when I plug in a 0, I get out a 0. And so sine of 0 times 3 is 0 minus pi is the same thing as sine of minus pi. And I think about what the graph of sine looks like, and yep, right there, it comes back at minus pi. It gives you out a 0. So yes, I've drawn this correctly. That looks great. This goes up to 1, down to -1. But now we need to do the stretches and the shifts. So 4 would stretch it up to +4 and down to -4. How nice is that? That's really easy. Isn't that cool? So, like, I don't need to redraw the thing then, but now I am going to need to flip it. And I'm gonna flip it first, then I'm gonna shift it down by 3. And one thing I notice is that that's going to change where this guy is. So this is where I'm going to bring in a dotted line for this new middle part right here. So there's my dotted line for where this thing happens. I know it starts here, and now when I flip it, I know it's going to go from here up first and then back down. So I'm going to start like this, up, back down, up, down, up, down, and all that. So that's the negative part. -4 sine pi right there. This x-axis still goes through here. I'm sorry, y-axis still goes through there. But now, instead of waiting and redrawing it all over again, why don't I just go ahead and take care of that shift? And I could just imagine if I took this thing and shifted it down, then the x-axis would be somewhere right. So to be a bit more clear about what I was saying, is like I know that since the amplitude here is 4, and then we're shifting it down by a factor of 3, I know that it's not going to shift it past the x-axis, right? If we were shifting down by an amplitude of, by a factor of 4, then I would know that, well, all these tips right here, if they come down exactly 4, then they would touch exactly at the x-axis. But here I have something of a height of 4, I'm only shifting it down by 3, and that's how I know it's only going to come down to there. So that's how I know to draw the x-axis right there. Now, if you're not comfortable with that, you could just do this part first, the sine stuff, and draw like this, draw like that, and go, okay, there's 4, there's -4. And then take this next step where you bring it down. If you're more comfortable with that, that's cool. But what I'm going to do, what I like to do is the way I did it. I do the dotted line first, knowing that that's where my sine, in this case sine curve, is going to have its middle part. And a nice thing about also doing that is I could say, well, since I've shifted it down by 3, then this right here, that point must be -3. Okay. You could also do this from reasoning with another graph, that's fine. So anyway, if that's 3, and we know that the amplitude is 4, then if I go from -3 up 4 units, I'll be up here at +1. If I'm at -3 and I go down 4 units, I guess I'll be at -7. 3, 4, 5, 6, 7. Yes, I'll be at -7. The only thing that remains is to label these parts, right? So I know that this point right here is this point. And so remember how I got this, right? I flipped this upside down. This was just 4 sine 3x minus pi. When I make it negative, I flipped it. And now I'm actually doing the -3 part as well, right? And so this was that part that's at 2 pi over 6. This part is pi over 6. This part here is 3 pi over 6, 4 pi over 6, and all of the above. Now, right now, for this homework, you do not need to label all of these points where it actually goes through the x-axis. You'll be doing that soon enough. So enjoy when we get there. For this homework, I'm not going to require it. That's fine. Could you go see your brother, please? I think he might need some help. Could you please go help him? I know, buddy. Okay, so that's the idea for these. This looks terrible, but this is minus 4 sine 3x minus pi minus 3. That's that guy. So that's a pretty rough one, right? And indeed, but I was going to do an example, but now we're really running out of time, that how we actually find these points right here. Not going to require, like I said, not going to require that for this homework, but in the future, we'll be doing that. You'll notice I've also included where it goes through the y-axis because that one's easy to see. And real quick, let's just check it, right? It should be here at minus 3. Let's check it by plugging in a 0 in for x. When I do that, the 3 times 0 is just a 0, minus pi, minus 3, okay? That's just sine of 0. I'm sorry, that's just sine of minus pi, which as we've already seen is 0. So minus 4 times 0 minus 3. That comes out to minus 3. So yes, indeed, the y value is minus 3 when the x value is 0. So my graph is good. I feel good about it. Now, one of the things, I'm not going to do a full-on example with this kind of thing, but watch what happens if we have, and we'll make this easy. Let's just go cosine pi x, how about plus 1, how about pi over, I'm sorry buddy, how about 2? Okay, let's say we want to do that guy. Well, that's going to change things a little bit. Couple ways we could do this. We could say, well, between this guy goes from here, and doing this real quick, we have a minus pi over 2. Let's see, that would be, well, let's just do it this way. Minus pi over 2. Dividing everybody through by pi, I get a minus 1/2. That gets divided by pi. That gets divided by pi. And so now we have an amplitude of 1, because we haven't changed it. The period now is 2. Let's just double check that. 2 pi divided by whatever number is in front of the x. That indeed is a 2. The phase shift is then a minus 1/2. And yeah, it should be in the minus direction, because plussing something to the input shifts it to the left. So yes, minus 1/2. Right? The other way to see that would be to factor this bad boy out, and we have cosine pi times x plus 1/2. I think I've done that right. Bring the pi back in and you get that. Yep. Okay, that's good. And so that should shift us left by a factor, or left by 1/2 units. So that's what the phase shift means right there. Now you'll notice something interesting. Now the input values, where all the interesting things happen, are not going to have pi in them at all. Huh, that's kind of cool. So let's see, minus 1/2 up to 2. So we know that the period is 2. So a quarter of the period would be 2 over 4, or how about 1/2. So this is actually an easy enough one to do just straight up. Just say, okay, here's minus 1/2. And we're counting by 1/2. So we go 1 to 0, 1 to 1/2, or 2 to 1/2, 2 over 2, 3 over 2, 4 over 2, 5 over 2, and etc. Right? And yes, it should end here at 2 minus 1/2, which is 4 over 2 minus 1/2, which is 3/2. So that should be 1 full period. Cosine, we know, starts at 1, and so it goes up to 1, down here, down, back up, and yes, 1 full period at, that looks terrible, at 3 halves right there. That's 1 full period. Okay. The 0 actually went through right there at 0. And let's just double check that. Plug in a 0 for x. You get cosine of pi over 2. Cosine of pi over 2 is indeed 0, so we have the correct looking stuff right there. Now that's interesting, right? So now this, I wanted to do this example because, oh, and finally, sorry, gotta have that in there. I want to do this example because the very last 2 questions on your homework gives you a graph and has you find find a function in the form of a sine bx plus c that fits the function. And they will give you something that does not have pi's in them, and that might freak you out. Well, this is how it happens. Turns out if you have a pi in front of your x, right? And I think this is in the previous ones too. There's 1 or 2 in the regular ones where this happens, right? Where now your maxes and your mins and your zeros occur at actually rational values. And so it's interesting that that could happen. And so let's just see. So here's an example of what you're going to see there. So this example was done. I mean, that's all we wanted to do. We just wanted to graph that guy. But now, there's another one. They will give you the graph of something and then tell you to find, to basically fit this to the graph, okay? So one of them that they give you, I'm gonna do something similar to it. Not exactly what it is. Now, when I look at this, I immediately think, oh, that's cosine, right? Cosine starts up there and it comes down and all that. But they're telling us to fit it with sine. So that's a tricky thing. I've had so many students like that just really throws them through a loop. They're like, yeah, but that's cosine. And as we saw, like, as you shift this thing, cosine becomes sine, right? So in this case, Peter, can you please go take care of Vinny? Please? He really needs a friend right now, buddy.
My knees hurt.
And so let's say that this goes up to 3 and down to negative 3. And let's say that this goes here at 2, 4, at 6, and at 8. So when you're given something like this is how I suggest you do it. First things first, like the amplitude's always going to be easy to see. Even if this thing has been shifted like way up or something, right, like this, you'll, like, in order for this problem to be solvable, they'll have to give you something like this. And then you could say, well, if it goes from 7 all the way down to -1, right, then the total height is 8. Half of that height would be 4, and so the amplitude would be 4. In this case, it's even easier because it's exactly split in the middle, right? It goes up 3, it goes down 3. You could say, well, the total height is 6, half of 6 is 3, right? Or you could just say, well, this is like sine, it's just been stretched up by 3. So we already know that A is equal to 3, okay? Now, for the rest of it, let's put this together. Let's think about this. From this graph, there is one thing like that. Well, there's another piece of information that we could get, and that's the period. You could look at how long does it take for this thing to repeat itself. Well, if we're here at 0, it goes 2, it goes 1. Oh, it takes a total of 8 until it repeats itself. So in other words, the period is equal to 8. Now, what we could do is say, but wait a second. We know that the period is the same thing as 2 pi divided by whatever number that is right there. And so if that's equal to 8, now all you got to do is find b. Solve for b. Well, let's multiply both sides by b. How about let's divide both sides by 8. And that gives me b equals 2 pi over 8. pi over 8 is the same thing as pi over 4. So that gives me my second. B equals pi over 4. So we're almost there. Now I just need to figure out the shift. Now, there's a couple different ways we could do this. The way that we figured this out before is like, well, with the phase shift, we can see like once everything's been stretched and compressed, you can figure that the phase shift is how much you've moved this guy. And now, it turns out there's infinitely many possible answers here for C. Like, it could be that I take this and shift, it could be that this was sine, and it got shifted out here to 6. It could have been that this was sine, it got shifted down here to -2. It could have been that it was this next one, or so on and so on for infinitely many. So I think what your book says is find the smallest positive value of C. So that's just to cut through all these. There are all those ways you could answer this. You could say that the phase shift was 6. You could say that the phase shift was -2. You could say it a bunch of different ways. Now, you can't say the phase shift was +2, because if that's what got shifted, well then that's not sine, is it? Sine doesn't go this way and then that way, right? Sine goes this way, so you'd have to pick this point here to bring back, this point here to bring this way, or the next one over, but it can't be this one or that one, otherwise you don't have sine. So, okay, so we could just say, well, and actually let's just do a couple of different ones. So we have B is equal to pi over 4, okay? So at the very least, we're starting to put this guy together. A is equal to 3, so we have 3 sine. B we know is pi over 4. X, now we just need to find out plus what? Or minus what? Now, a couple ways we could do this, and I want to do it for 2 different points. Let's say that this is the phase shift. If you remember from earlier, the phase shift actually, the sign gets taken care of here. So the -2 being the phase shift. There's a couple ways that we could get it. We could use the definition C minus C over B. If you remember how we got that when we put the AX plus B in between the stuff, and then when we brought him over, he picked up a minus, bx plus c. We brought the c over, he became minus. You divide by the b, and that's why you have that. And whatever sign that ends up being, whether c is positive or negative, it's all taken care of. So we could just do this and say, well, -2, that's like my minus c over b. We know what b is. So that gives me minus c over pi over 4. So if -2 is equal to minus c over pi over 4, then what we could do is just, well, notice negatives and negatives are gone. Bring the pi over 4 upstairs. So that c would have to be pi over 2. And then we'd be done. We could say c is equal to pi over 2. And it would indeed be a plus pi over 2. Now let's just check that, right? We're saying that this thing, well, if it was a sine, I'm taking this out of here. If it was the sine function, we know the sine function did this. And then if you took it and compressed it, compressed it by a factor of pi over 4. So this is what you've done. You have your sine pi over 4x. You've compressed it. Now you take that thing and you shift it left 2 units. That's the same thing. That is what you would get if you had pi over 4. And then instead of plugging in an x, right, we shift it left 2 units. It would be x plus 2. That's how you would make this shift right here. If that's your function f, and you need that point to go to the left 2 units so that this becomes that, you would plug in an x plus 2. So here's your x plus 2 that you're plugging in. Right? That's what I've done here. And then this guy comes out to sine pi over 4x. That guy jumps over and gives you plus pi over 2. But this suggests another way you could do it, right? Once you know your B, you don't necessarily need to do the phase shift thing. You could just say, well, like, the B, I mean, just do what I've done here, and then just say, well, how far has it been shifted? You need the pi over 2, and so there's that, and then you could find the phase shift, and so on and so forth. Now, this would be the one that they're looking for, because they say the smallest positive value of C. So, positive value, meaning that it should be, the actual thing should end up over here on the left, but let's say that you didn't know that. And you said, well, let me try this one. This is the one that needs to be shifted. And so we could do that. And we'll do that first this way, and then. So you have your compressed sine already. There's your compressed sine.
I can stay here all day.
It's been compressed by pi over 4.
I want to stay.
Okay, buddy, give me another minute, buddy. I'm sorry, you're doing really great. I really appreciate it. Now, if we need to take that function and shift him to the right by 6 units, we would need to go sine pi over 4 x. Now, to shift right, we subtract, so minus 6, and then that would give us sine pi over 4 x. That guy jumps over. A 6 over 4 reduces down to a 3 over 2. It's a perfectly good answer, but now you could look and see, is the value of C positive? No, it's not positive, so already that's not what they asked for. Also, which one of those is bigger in magnitude? Well, that one's much bigger in magnitude than that one, so they must have meant that one right there. Another way we could have done it is if we said that's that. If it's been shifted by that far, then the phase shift is 6, which is equal to negative C over B, which is equal to negative C over B is pi over 4. And so we bring the 6 upstairs. Or, I'm sorry. So that's the same thing as having 6. Negative C over pi over 4. We'll bring the pi over 4 upstairs, and that gives us 6 times pi over 4 equals negative C. Therefore, positive C is negative this stuff. 6, 4 reduces down to 3, 2, and we end up at the same place. So the thing is, right, they want a positive one. If you pick this point for your phase shift, well, if it's positive, then the phase shift is going to be negative. If you pick the negative point for your phase shift, then your C is going to be positive. So that's how you deal with it. I hope this is enough. I hope this goes out early enough for you to see it. I will see you guys on Tuesday.